However, first, I have this very bad habit of not introducing myself. I'm Alex. It's very nice to meet you. Thank you. And as a matter of fact, I'm from Iași, so it's glad to be home and return. So after the conference is done, I'm going to go back to my grandmother's place where I grew up and check how the wine harvesting went and all of that stuff, right? So let's get it rolling and see what we have for today. For today, I want to look at how generative AI works and what can it do for urban innovation. We are seeing it everywhere around us, and we will see it more and more. However, let's see what can it do for cities specifically. Then, let's see how can we build an autonomous system, a system that can take real-time decisions for the citizens and adapt on a day-to-day basis. And then we need to see what means we have together, because it's important to create all of these things, but it's important to see what infrastructure it's going to run on, where it's going to be placed, and so on. And then we'll have some time for Q&A. So first, let's see how can we unleash generative AI for urban innovation. What generative AI has special compared to other AI branches is that it has this human touch. It has this effect of bringing everything together and making it very, very easy for the users to interact with generative AI-based systems. It has this human touch that we would spend a lot of time and effort to develop. While with generative AI, we can pretty much get that out of the box. For example, we can democratize access to advanced analytics. We may have a lot of traffic data and a lot of usage information about the pipes going throughout the city and so on. However, it's very hard to tell pretty much anything based on that. We need experts, we need to invest a lot of money. We may have all of that in the private sector, but in the public sector, not so much. You would need to go to some vendor that would bring that expertise. However, now it's possible to get all of those insights based on the data without specialists, or at least in the short to medium term. What we can do with generative AI is, for example, ask for how many years do we see a water system running? In how many decades will we see corrosion? What's the expected lifetime based on the corrosion we see right now, and so on? Or we may ask, when are we going to need to maintain roads, the roads that we just built, based on the daily usage. We may have a lot of traffic data that may be accurate or not. We'll see how to get accurate data for traffic. But even if we have all of that traffic, we would need, again, to bring a specialist to do some sort of planning and modeling and so on. While now what we can do is just simply ask, using natural language, what's the load going to be in 20 years based on the current data? What's the pipe corrosion going to look like in 10 or 20 years based on the number of people living in that area, based on the system's load overall, and so on. And overall, like I said, generative AI is going to immensely facilitate the user interaction. And that's for both specialists working in certain domains like urban planning or electrical circuit engineering, electrical grid engineering, and so on, or us. For example, if you want to ask, okay, how do I get a building permit for my house? Usually that's a very lengthy process. You need to go into 10 different areas, but with generative AI, you could have a unified point of contact. And building up on that unified point of contact, you need some sort of unified way of accessing your data. Right now, the data is living in multiple data silos. Silos with different APIs, different means of accessing the data, different means of loading more data into them. While what we need is to break those data boundaries. And we did that through two key enablers. If the data is in our system's preferred data location, if that's in an autonomous database or data warehouse, we have Select AI. which is a great way of interacting with your data using natural language. You just ask the question, and no matter what type of tables you have, regular tables, CSV tables, XML tables, and so on, you will get your answer. So if you're a business analyst and you want some information, you don't need to go to your IT team and ask, build me this report. You can just ask for it yourself. However, data, like I said, is in many locations. And sometimes you may have it in Elasticsearch if it's logs, usually about our system, or we may have it in Mongo if it's user data or Postgres and so on. We have our own proprietary data store retrievers that, just like the Select AI, whenever we ask a question in natural language, they will first look at the available data sources, and that could be tables. If it's tables, they are going to look at the definition of the table, generate a SQL query behind the scenes, automatically invoke it, and then interpret the data and return us the description in natural language. So once that happens, we integrate that output in our pipeline and eventually reply to the full question. Some of the data, some part of the initial question may get answered by this, or the entire question may get answered by this. However, there is more to the pipeline, and the pipeline can have a linear nature, where we get from the query to the response. The query could be something simple about Paris. And if you just ask the first question, it seems pretty straightforward. But if you want to make the system context aware, so we are in Iași now, so we may ask something about Iași. But at some point, we may know we are talking about Iași and just call it without referring to the entity. What our system does is to first rephrase the question based on the context and replace placeholders like it with the original entity. Because for us, it makes sense. But for an AI system or for anyone else that hasn't been part of the conversation, it won't. AI has a surprisingly human nature. We designed it hoping to replicate what we have in our heads. Not that it would be so great, but if you think about it, we never really reached that. So it's somewhere below that. But just like we understand conversations, AI will do the same. If you don't give it the full context, it won't really know what to reply back. So we first rephrase the question and then formulate a standalone question that has the name of the entity in charge, information about the context, and so on. Once we do that, we move forward and select the data sources. And like I said previously, we can connect to any data source. No matter if we have pre-built connectors, or if it's a new data source and we want to automatically generate queries, execute them, and interpret the answer in real time, we can do that. But we may have some data sources about the live weather information of Iași. We may have the Iași wiki page as a data source. So depending on the question, we may want to choose one or the other. If the question is, tell me more about Iași, we may want to go to Wikipedia, load that into the LLM's context, send the question, and then reply. However, if the question is, if we're talking about Iași, if we're saying that we're living in Iași, and we are asking, okay, can I go with a short sleeve outside? Then the LLM will figure out it needs information about the weather. It will automatically select only the weather data source, and not the wiki data source. Since that's general info, that's not relevant. And that way, only the relevant data source will be used. The data loaded and sent to the LLM is greatly reduced by filtering the data sources themselves instead of getting all of the possible information and filtering that. And once retrieved, it's finally inserted in the last call to the LLM, where we generate the response. And we generate that response only based on the retrieved data. And we make sure that the previous knowledge of the LLM is not used. When we as humans may have some prior information for any discussion, and you are tempted to bring that in. In some cases, it's what we want, And it has that wow effect, since you can ask GPT or any other LLM demo questions and you could get answers. However, if you ask something specific about some numbers from the football for the football match from the last evening, it may reply with false data, and we don't want that. We are working in the enterprise environment with lots and lots of data, heaps of it, and we want specific questions. We want specific answers to specific questions. For example, what's the comparison between the last 2 quarters for this given product? How did the marketing campaign for this product improve the conversion rate? Right, and so on. There we don't want the system to hallucinate. We want the ground truth from real data. Then we are actually enhancing the system with reasoning and action. We don't stop at replying to the question, right? We want to also integrate actions. Sometimes we could ask the LLM to take complex actions that have sub-actions, or actually directly tell those sub-actions. However, we want the system to reason and come up with those either way. We may tell it, book me a flight to Paris depending on the weather, or book some seats for the movie tonight. We may want the system to figure out that we want it to be sunny based on previous interactions. We may want to be specific and say, book me a flight to Paris if there are above 20 degrees outside. However, whatever bucket we are in, we want multiple steps. We need multiple steps. So the first step is the reasoning, where we figure that out. The very first thing the system will say is that, okay, first I need to retrieve the weather data. It will retrieve the weather data about Paris. It will do that by going to a tool, to a sub-tool in the system. That will retrieve the weather and feed it back to the reasoning step. Now the reasoning will happen again and say, okay, we retrieve the weather info. Is it above 20 degrees? Yes, it's 25 degrees. Then I should book a flight. How do I do that? Then it will look in the list of tools and call the tool capable of calling the airline's API. Book a flight. It will return the response. And if the action is successful, the system will finally return to the user with the ticket and say, look, here's the ticket. The weather in Paris is above 20 degrees. So I went ahead and booked the flight. Or we can ask a user confirmation before that, and so on. What's special about this graph-like system is that it excels at third-party integrations. And the foundations are pre-built. We only have to define the integrations as tools or nodes, the primary difference being that nodes have access to the full context, while tools have certain pieces of information extracted by them, by another LLM, of course. We want RAG to be a node because we need full access to the history, like I explained before. We don't want an LLM to narrate all of the history and potentially modify that, since that's always a potential issue with AI. We want direct access to the raw history and use it. While for the airline API calling tool, we need to extract the name of the person traveling. We need to extract the date and the exact hour when the person needs to take off and arrive. So that's an ideal case for an LLM. Debatable, we need to hard check that with the user before we actually book the flight. But that's information that an LLM will excel at to extract from the context, while any predefined logic, any predefined algorithm would likely fail. And no matter how cool and how promising our systems are, it all boils down to security and safety when we deploy. If that's it's not okay if we are not within the threshold, the project won't fly. Security is something we dealt with for decades. That's fine. There's not much innovation happening there. We can make sure there are no vulnerabilities, no interruption because of no interruptions because of attacks. Make sure the access to the data is controlled through means that have been around for decades. What's especially hard with generative AI is the safety. How do you make sure that through visual interaction you're not going to get attacked? For example, if I ask the system to do anything on my behalf, what's there stopping the system from doing that? Since it's an LLM, it will try to answer politely to whatever you say. And now that we are giving it tools, it also has the means of calling tools the way you ask it to, right? First, we analyze the intent. And if it's a prompt hijacking intent, we are telling the user that, and we are politely asking to ask something else. But we stop right there. That request won't even go to the LLM. That will stop right there, and we'll just serve a predefined response. Or we may have confidential data. And when we deal with confidential data, it's important to make sure of the data that goes in and the data that goes out. We may have people sending a picture of their car and say, where is that code the shop is asking me to retrieve from my card? Well, that's confidential data. And if by any chance it goes into some database for fine-tuning, then the LLM will start replying with that person's confidential data, which is not good. That must have happened at least sometimes, so we don't want to be among the ones doing it and perpetuating it. So if we detect sensitive data, we either censor it or stop right there. The same goes for data going out. We may have a system for some mobile carrier company, and their operators may need information about the customers to reply to certain requests and to service requests. However, we may not want them to know where the person lives or what's their birth date or place of birth and so on. That information, were it to be part of the information fed to the LLM, could be censored when going back to the operator. And the operator would just see the active products of the user, how long it has on the current subscription, and stuff like that. And all of this has to be monitored. We can create systems that are great, but I think that the trick is, and our value is in the future value-adding services and the value-adding updates. And for that, the most certain action we can take is fully record the actions taken by our system. We need to record every interaction, make sure it goes okay, and if something goes wrong, we must absolutely know every detail. So we are continuously tracing every step of the LLM, every step from the question to the data source selection and so on. And if something goes wrong, we can fully trace the customer journey and dig in and see at which step something went wrong. And of course, based on that, we can do automated evaluations or semi-automated evaluations on metrics of our choosing, be it usefulness, correctness, factualness, and politeness, and so on. And eventually, based on the gathered data, we can do fine-tuning as well and invest hundreds of thousands or something like that in fine-tuning. But when we do that, especially since it's tens of thousands or hundreds of thousands, we need to be absolutely certain we have good data. And one crucial step is the data validation. Before we even start building a system and before we even get close to production, we first deal with the data. We must make absolutely sure the data is clean and it has what we expect. Otherwise, we'll just poison the AI and confuse it. and especially for generative AI, since a lot of the information is coming from unstructured sources, there are companies using emails as the primary data repository with lots of documents messed around and so on. We want to make sense of that and give it to the AI. However, if we don't cross-check it and we don't make sure that our parameters are the best for extracting chunks, for keeping the cohesion high, while decoupling certain unrelated topics, for example, the technical requirements of an excavator are very different than the maintenance requirements. And questions about those will probably be unrelated. We don't want to fill up the context with unnecessary information. So that we want split. However, if we have many technical requirements, we don't want to simply stop at half and forget about the rest. We want those technical requirements to stay together. We want the cohesion high in that case. And that's where our platform excels. We can check that, validate that, and only then ingest the data. So that's how we make sure that the data going in our system for generative AI-based systems is right, and we give the most accurate responses to the users, be it a citizen or a public official. But now, let's see one of those specialized AI branches that I mentioned, one of those specialized AIs that can be called by generative AI as a tool. One of those is computer vision. I specialize in computer vision. I dealt with computer vision, obviously for intelligent cities, but also for retail, commercial spaces, manufacturing, and many other verticals. And I want to look at the common traits of all of these verticals. So one of the key aspects is the data residency and sovereignty. That's a fancy name. I thought it would do wonders for the presentation, but what it actually means is fully controlling your data. If we think about fully controlling, let's say, some toy, right? Or a certain appliance, a certain household appliance. Do we want to remotely operate it? No. We want to be near it so that if it somehow goes wrong or if it goes off course, we are there to handle it. The same goes for the data and the data processing. The best way to make sure no one is touching it is by being right next to it. We want it locally. And this is mostly what edge computing is, locally storing and locally processing your data. By keeping it local, you greatly reduce the attack surfaces, and you can even physically limit the access to your data. So that's a huge help, and it's in a very good amount of use cases a requirement, especially if you're in EU. And if you are dealing with video data out of all types of data, the requirements are even more specific there. Store owners, security officials from the town hall will never agree of their data leaving the premises. Or they may say, so yes, let's do that, but later on, when reaching full-scale rollout, you'll likely encounter legal issues and everything will come to a halt. So it's very important to design your system to be legally compliant first. And then, like I said, the data is hardly transmitted anywhere. It's processed locally. So you can slice and dice it no matter whatever way you want, and you can have tailored security measures. Whatever you want, that's the way it's going to go. And data and privacy and the regulations aside, there is a very important performance aspect as well. Sending data to the cloud means bandwidth, which is often limited. Some locations have their bandwidth limited to megabytes, and I'm talking about big commercial spaces, and that's a reality even in Romania with our networking infrastructure. And that's also some time lost in the process. You waste some time to send the data, you waste some time waiting for the response. That's a lot of latency. lots of latency compared to local processing. And that could be milliseconds or tens of milliseconds. But in in an autonomous system, in a critical application where decisions need to happen in real time, that's often not that's not the luxury you want to take. That's not the luxury you have, and that's not the risk you want to take. On top of that, relaying data involves some way of communication, so some connectivity. If you need to send your data over the internet, you may or may not have that connection. And internet connection is intermittent. Factories may may go without internet for months, and that's a real use case. I saw systems crashing, not when the internet would go down, but crashing when the internet would go up, because the data gathered, meanwhile, was so huge that when the data was sent back to the cloud, everything crashed. The load balancers, the data stores, and everything went down. So by having the compute next to you and the data next to you, you no longer rely on that. You have a safety in case of intermittent connection, and you will always be able to take those critical decisions. And generally, if you are talking about stores, you'll have some compute in every location. If you do location analysis and location intelligence, if you're talking about autonomous vehicles, you'll have some compute in every machine. So even though the deployment size may grow, and over the years you may grow more and more locations that would yield more data, so will grow the compute. So edge deployments are organically scaling. You don't need to design everything from the get-go and rely on that. You can organically add and build your system in such a way that even if you need more compute for a single location, you can eventually add more nodes to that. So in this image, we can see an intersection that's fully blocked, where everyone hates being in it. However, not a single soul from there wanted to get in that situation. Sure. Yeah, it's... yeah, because we never want Yash to go that way, right? Not sure if that was... Okay. Thank you, anyway. So what went wrong here? Basically, everyone defected and played in their own advantage. They didn't take the chance of letting someone else pass, just to make the system fluid and so on, because in return, they weren't sure someone would let them pass. So everyone rushed ahead, the intersection got blocked, and that's the end of the day. You are not going to move from there. However, were we to be aware of each other? Were we to have some sort of system that would be aware of every car, perhaps of the car's intention, where does it want to go, what's the trajectory, and so on, we could make all of this so much more fluid and dynamically adjust the waiting times and so on. However, that's not going to happen in this century, most likely. We have intelligent cars capable of that, but how many are there? And we have good old cars being produced nowadays as well, and those will continue to work for decades. And we need to take into account all of those cars as well. So we cannot rely on cars being smarter and doing that. That won't happen in this century for sure. What we can do is perceive, and we can work on our perception and make sense of what's around us. The best way of doing that now, without having smart means, are the cameras. There are intersections with dozens of cameras which we are not utilizing. The cameras are the very eyes of the city. We can see what's around us, we just have to extract that information. So now let's see how. We are talking about a very big scale. We are talking about hundreds or thousands of cameras. And we need the information to be extracted in real time because we want to feed that information to emergency services and reply within milliseconds, almost, without milliseconds every time. So sending that information to the cloud take a lot of time, would be costly, and processing it in the cloud would be way more costly as well. And then getting all of the responses back and so on, making sense of them, that's not going to work. So what we need is to process it locally. First, for every camera will send data in a different encoding and in a different container format and so on. We cannot expect every camera to have the same parameters, and that's simply not a reality. I've never encountered a deployment with a unified set of parameters. That's not a reality, sadly. I've seen even commercial spaces with cameras from Hikvision, Sony, Bosch, Dahua, and every IT manager that came in had a different deal with someone else and brought a different provider. Well, that sort of works, I guess, for people looking at screens, but we have to make sense of all of that screens. So you need the process per camera to decode the information. Once you decode it, you'll get raw images. Raw images are what's going to be eventually used by your system, by your AI to make sense of. Encoded data is not going to help. But once you get the raw information, and you can do that on the GPU, and you should actually, because on the CPU it will take a lot of time. On the GPU it's also easier to parallelize and process, so having a dedicated chip would generally be recommended. If not, a GPU is fine. Then once you get that data, you need to batch it or max it. You need to batch it because later on we want to process that in parallel and extract observations from every image in parallel. We don't want to have that to happen sequentially. If you process that sequentially for thousands of camera, which is thousands of images at once, then that will take ages just to make sense of a single frame. So that has to happen in parallel. Then you can do inference. And you can do inference in parallel using higher level tools like TensorRT. TensorRT is what's used under the hood for TensorFlow or PyTorch and so on. TensorRT is NVIDIA tech. There is ROCm, there is the ROCm ecosystem for AMD as well, which is not that developed, but they made some smart moves in that area. And below TensorRT, there is CUDA. CUDA is the fundamental layer for accelerated GPU processing. And where AMD played smart in this case is that they created an API that's identical to CUDA. So it's whatever app you have written in CUDA, you can then magically compile it in using the ROCm software. The ROCm software, which is obviously not going to work. That's just marketing. But okay, they at least made a smart move. So coming back, you can do that inference in real time, in parallel, processed on GPUs. And once you get the entities from the primary layer of inference, you'll get entities like people, cars, bicycles, all of that. And you want to keep track of it. For every new frame, you don't want to just start from scratch and get a new set of cars and images. You want to keep track of it across frames. So on a frame-to-frame basis, we will track it in a GDPR-compliant fashion, because that's mostly related to temporary features and location in the frames. And once we do that, and once we have a unique ID for every object in the frame, we can extract some secondary information that we do only once for the lifetime of the object. The color of a car is not going to change. So we are not going to waste compute in inferring the color of the car in every frame. We will do that once and then reuse it. We will reuse that metadata. We may redo the inference if the car comes closer, or something like that. But we are going to do it in a smart and efficient way. And finally, once you extract everything you can locally and anonymize everything, you can send the data. You could send it, locally you could have it on screen for that regular live monitoring on screens. You could record it on the disk and do it like an NVR and just record it to the disk, or you can send it out to a message broker. There are many options like Kafka or Confluent, which offers Kafka for enterprises. That's mostly what I worked on. And honestly, I never found a better competitor. Right, and then once you send that to the broker, you can send it even to the cloud, because now you have lightweight data that's metadata only, that can be stored and processed in the cloud. In a city, you'll have a lot of video sensors, be them Wi-Fi cameras, bullet cameras, or dome cameras, that are going to be connected to your edge device, the device running the accelerated pipeline from before. And then once all of that data is extracted, it will go from the clouded customer silo, which is the edge computing silo, to the public cloud, perhaps, or the sovereign cloud or private cloud. That's up to us. So we can choose if we're sending it to a public cloud like we're used to, or something dedicated for us. We first need to store it for long term, because we never know, we never delete data. What happens now is that cities are simply deleting data because they generate too much and they have no idea what to do with it. Even the video contains lots of data, but every 30 days or so they just delete it. So we want to store the cheap metadata in the cloud for indefinite use. We may send unstructured data to an object storage option, and structured data, or partially structured data to an autonomous database or data warehouse. We have plenty to choose from. Then we want to process it. We want to extract information. Fine, we extracted the low-level information, like the amount of cars going through an intersection, or the amount of people walking on a sidewalk. Where do they stop? Do they stop for a coffee? If they do, then where do they stop next? Do they go to work and stop at a clothes shop? Most likely not, right? But we want data to validate that. We can extract all of that with AutoML services that build models right from the data stored in our database. We can run accelerated pipelines on GPU VMs, and we can finally aggregate all of the data and interact with the user using generative AI. So we fundamentally need to process that data in some way. And then once we get the insights, we need to analyze them. And we can do that in a dedicated analytics cloud. I have always built systems sending in dashboards. And every time there would be a new vertical or a new use case, we would get in touch with the stakeholder and ask, okay, what do you actually want to see? Well, I want this, that. That was a repetitive process just about customizing a UI, which is okay, but far from being great. What you can do now is let the stakeholder tell what it wants, and a generative AI-based system will make sense of that and will generate the dashboards on the fly. So even that automation got automated. And if you have custom apps, if you need custom apps that take certain actions and so on beyond what the dashboard has to offer, we can build apps in Apex, a free service running on the autonomous database that's low code. It's just drag and drop. And once you have the look and feel of your web platform, you can just define the logic behind the scenes using PL SQL and access any kind of web service you want. And now let's see what means we have to row to the edge. Nowadays, there are all sorts of offerings for the public cloud, the sovereign cloud operated by EU citizens. And the bucket we're interested in is the at customer bucket, which brings the compute and the storage to the customer. And now it's a matter of how close we want to get. Do we simply want security? If we want security and private access, we can have a dedicated region cloud. And that's a region dedicated only for us. We may want the compute for custom applications and custom platforms. Then we have compute cloud, which can bring a few racks or an entire data center in our backyard with minimal latency and the utmost security and privacy. Or we may want even the data, and we can bring a dedicated appliance for our autonomous database, handcrafted even at the level of the drivers for our databases to get the most out of the hardware we pay for, and therefore minimize costs, energy consumption, and so on. And now the cherry on the top is that you no longer need to manually manage your edge deployments. You can have those managed for you in a box and have everything you used to have on the cloud, all of the security management services, all of the high-level abstractions, right in your backyard. It doesn't matter whether you have internet connection or not, it can run purely offline. It can be on the top of a mountain or in the middle of the desert. It won't mind being surrounded by dust, it won't mind being rained on. It doesn't really care. And like I said, the best feature is that it's managed for you. I once had to climb up a pole because I installed an edge device being connected directly to a camera. And at some point, something went wrong. It wouldn't work anymore because I broke it, obviously. Didn't say that at that point. And it wouldn't have broken were I not to SSH directly into it and have to delete data from the disk because the edge management system from Azure wouldn't do its job, right? So were I to have all of that dealt with, the device would be up and running now. Now it's not, by the way. So that was a deal breaker and that failed. Why? Because we had to manually manage all of that. And we can see a clear trend of edge computing coming back. We can see Deutsche Bank going from cloud to on-premise and moving from 7K databases to 2K databases and have a huge decrease in costs and energy consumption. We can see Vodafone doing the same on a slightly lower scale, but still, and applying that for governments and digitalization. And we can see NRI managing multiple banks and having their data in the most secure fashion possible on a dedicated region. So depending on what you need, you have all of the means to accomplish that. If it's just security, then that's fine. If you want the best latency and the best performance, we can do even that and bring it in your backyard. Thank you for having me, and if we have time for questions. Then
sure, we always have time for questions. Any questions, please?